Check, 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 check. Hello? Hey, we got a viewer. How's it going? Right? All right. Let's get into it. Zig BFT. Yes, sir. Yes, sir. That's what we're gonna do. We're gonna try doing some stuff in Zig. We're gonna what we're gonna do? We're gonna build hash graph consensus. So uh that's like blockchain, but version 2 basically. Yep, 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 yep. Let's do it. Zig. Make clear. Let's call it mycelium, right? CD mycelium. So I have no idea how to do this, but we're gonna learn together basically. So get this set up, Zig in it. Can you guys hear any music by the way? Is that working? Okay, okay. So main.zig. Let's get rid of this. Delete this. Or speed W, buffered writing. Okay, we don't need that. We just want to do this. Right. Let's see if that works. Hello. Zig. Zig. Run. Source main.exe. Main.zig. No. See, that's why we do these things, so we can, fix the build issues. 2 arguments expected, 1 found, so that would be this. Hello world, perfect. We got it. We're moving. So, how are we gonna build this blockchain? So, here's how we're gonna do it. Hash graph. So, this is like an alternate to blockchain. It's not really a blockchain, but it's like it's a distributed ledger, right? You can store things in a decentralized manner, transactions and whatnot. And so it's a little different to blockchain. And yeah, let's see how it works. Hash graph consensus. Okay. Okay, so basically you have a bunch of nodes, they're gossiping, they're bouncing around their messages, bounce, 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 and yeah, it builds this kind of hash graph data structure, and then that's how it determines the ordering. I don't really know the details too much, but we're gonna figure this out together. Trying to find this paper I was on. That was really yep, this one. So first we start with this, right? Events. So that's kind of the message they send during gossiping. Uh, okay, altcoins event. Okay, okay, event. So what is it? What does an event need? Basically, it needs a timestamp, which would be I don't know how timestamps are stored in Zig, but I'm gonna assume it's int. How do you do structs in Zig? I forgot. Zig structs. Something like this. Structs. Yep. Timestamp I32. Cool. What else do we need? We need hash. Hash would be a string. We need transaction, which is like a generic struct. Sender, receiver, uh, digital signature, the cryptographic signature of the creator. Okay, that's cool. Self parent hash, other parent hash. Awesome. Self parent hash. Uh, wait. Other parent hash. Signature. You wait. U32. No, I32. I32 mean transaction. Oh, that's amount, let's say. Okay. Okay, so now we have the basic. No music. DAG. Yeah, DAG. Directed acyclic graph. Yep. Alright. So we have the event, we have the transaction. Timestamp, hash, other hash, signature, transaction. Cool. So gossip. What is gossip? Let's see. Consensus uses a gossip protocol that means that a member such as Alice will choose another member at random. Okay, so they're sending messages between each other. They do it. Messages spread exponentially fast. Synchronization between through the gossip sync. Upon completion of a gossip sync, each participating member commemorates the gossip sync with an event. An event is stored. Oh, okay. Wait, what are they gossiping about? Because I thought they were gossiping about events, but events happen when you have a gossip sync. So what are they gossiping about? You know, so far, Alice. What does Alice know? What the hell does Alice know? Event is stored in memory as a data structure composed. Okay, so we got an event. Last event created. So that's kind of like a blockchain. How you have the encrypted last block. The events are kind of like blocks. For example, Alice and Bob performs a gossip sync. It seems to be something. Appreciate it, man. Thank you. Uh, see, parent hash, Alice, gossip sync. Other parent hash would be the last group. Alice and Bob perform gossip sync. Parent hash would be Alice created prior to the gossip sync, and the other parent hash would be the last member. Okay. Gossip continues until all members have received the new created event. All right. Let me get ChatGPT to break this down for me. So, ChatGPT, explain this like I am 5. Friends. No, that's a bit too. That's a bit too. Explain this like I'm a regular programmer. Soup. Hashgraph uses a gossip protocol, meaning that each node, say Alice, randomly selects another node, Bob. Okay, so they're sharing information between each other. Every time two nodes sync, they record an event. Tamper-proof about gossip. Now this is where it gets interesting. Via hashes form. Okay, I get this. This basically this represents the full history of each node. All right. I'm just confused. Right. What are they sending in the gossip? Because they're gossiping about something, and then that becomes an event. But what are they gossiping about? Is it the transactions? She has that Bob. How does Alice know that Bob hasn't received an event? Transactions, one would assume. Yeah, but ChatGPT is saying, they're not specifying here, right? Unless I'm missing something. It might be transactions. That's what I would assume as well, but let's see. Alright, let's try building a node. Const node equals struct. So what can a node do? A node will be able to pub on sync, and I'm guessing that would be to another node. It would have its peers. So peers would be yep, or maybe array list would be better. What is it? List, array list, standard. Yep. Okay. And then let's see. Add peers. Pub one add peer is so append. What would it be? Append slice. Append slice. Right. But it takes a const. That's fine for now. Okay. Cool. This doesn't have to be that, right? Yeah, yeah. It'd be better to be like that. Because this means this function doesn't mutate this at all. So it's like a guarantee. Okay. Peers. So then the next thing I guess would be to maybe buffer the events and then sync them across. Is true. Past events. Let's see an example actually. Let's see hash graph consensus example. Node. What is a node doing? Node missing events. Okay, so it's keeping track. It's keeping track of the missing events. Data transfer object. All sync events. Okay, so the hash graph is literally in memory. That's cool. Let's do that. Hash graph. Need a hash standard hash map. What's a hash map? So what is the hash graph there? So the hash graph is pair address to pair events. So that's how it tracks the known events, and then you just have the events as a flat hash. Okay, so you have track the pairs, known events, and then all the events. Got it. Let's say points. I'm not sure if it has to be a pointer. Let's make it not a pointer, because then we don't have to worry about allocation. Yep. Events, map string, event, map string. Has to be a pointer anyways. Okay. Actually, array list. We'll see if it's dynamic. I'm not sure if it's meant to be dynamic. I'd assume so. To be honest, if this has like pointers to events, wouldn't it make more sense to just store the ID? Let's see what's happening. Okay, so that's how you get missing events. Cool. That's the sync protocol. So what's this doing? What is it doing? Let's see. All the pairs. Make an array. Get the pairs from the hash graph. Transactions. Generate transactions. What is that doing? Oh, okay. Just generate some random transactions. Okay. So it adds the missing events to the local. Okay, that makes sense. So every you create some events. Now every peer is missing those events. Cool. Store the transactions temporarily and reset the global buffer. Okay. Okay, so you have some kind of buffer for transactions. Reset it, and you're gonna make an event. Event has a bunch of transactions. End address. What's end address? Node address. End hash graph. End address -1. Oh, so that's your ordering of events. your address, event, sender address. By a witness of view of them. Find the order. Okay. Alright. Alright, let's meet GPT to sense. ChatGPT is a great learning tool, by the way. Just put in a lot of information and just make it simple. Alright, alright. I think I get it. I think I get it. I think I understand a tiny bit. Let's have a go. Dashboard for events. So first step, gossip sync. Gossip sync. That's this. Right. Missing events. Get. So this would be like a RPC call, but we're just gonna do it local for now. I feel like I'm missing some information from this paper. Okay, I need something more detailed, basically. I wanna get a more detailed understanding. Hash graph, consensus, mechanism. Does Wikipedia have anything? No. To go check out the code base. All right. Let's see. Hydera. I think it's Hydera. Hash graph. Hedera. Hedera. No, Hedera. GitHub. Let's see what they have. I don't because the hash graph is different from the entire blockchain protocol. So we'll see. We'll see. Maybe we can take something. That's the node. New block node service. Mirror node. Consensus node, mirror nodes. So they have two different types of node. Node Explorer. Oh, interesting. The Linux Foundation owns the hashgraph protocol. Let me see, hashgraph GitHub implementation. Something more specific, like specific to hashgraphs, right? So this is C++, right? This might actually be intuitive to the Zig. You have to manage the memory. Event.hpp. Unordered set. Ancestors seen. Oh, string. Okay. Hash seen, hash not seen. This is even more complex than Go, to be fair. Okay, so it's caching everything. The seen events, unseen events. Rust. I feel like code written in Rust is just easier to understand. Greater self parent, other parent transactions. Okay, so that's what I have. That's what I have here. Self parent, other parent, signature, timestamp, transactions. And they're using a vec. I think array list might be fine. Slice might be fine because it's immutable, right? We'll see. Events, creators, peers, your ID. Doing WASM. WASM. Why would you need WASM? What's WASM for? WebAssembly. I mean, it says like 10 stars, so they're probably doing it for some reason to visualize it. Okay, that's cool. That's cool. I like the Go implementation the best, to be honest. Go implementation makes a lot of sense, but it doesn't really map to the model of Zig too well. Rust Zig would be Rust is kind of like a garbage collected language. You just garbage collect in its type system. You don't really manage memory in Rust at all. Very, very rarely. It's pretty much garbage collection in types. Where did that other paper go? Hashball. That's got created by the software Alice Bob. Hashgraph consensus uses a gossip protocol. This means that a member to so I understand this. Just sending events, hashing the last event. get all the peers, generate some transactions, event.missing events. Add the missing events to the hash graph. Okay, that's something we can do. Let's try doing this, because this, I think, is possible. So you need a sync events DTO, and so that this is basically the message they're sending during sync. So they're not actually sending events, they're sending some data transfer object, and that will contain the missing events. Sync events, missing events, sender address. Pretty sure it's like that. Also, hash map iterator. Zig. How do you do this? How do you do this? Alright, next value. What about regular iterator though? Keys. Okay, I think this gives you key value. Key value. Key pointer. Right. Let's do that. Then we're gonna do this. So we're adding the missing events to that. Missing events. Let's see. What is the point of doing that? Array events. man, this has been a struggle. I cannot lie. It has been difficult trying to wrap my head around this, but we will do it. We will do it eventually. It just takes time, you know. It just takes time trying to learn all these things. But but it's cool stuff, you know. It's cool stuff. I'm interested in how this all works. Blockchains, hash graphs. Blockchain V2, baby. Blockchain V2, man. Right. Okay. So I think I'm gonna leave it there for now. Uh, Progress hasn't been as great as I've wanted to. Obviously, we didn't get too much done, but I think we learned a lot. And so yeah, I'll leave it there for now. Thank you guys for tuning in. Appreciate you all. Appreciate my 2 to 3 viewers for sticking around. I'm grateful for it. Thank you guys. Appreciate you guys. All right. Love. Peace. Goodbye, guys. Have a good one. Have a blessed rest of the evening, and goodbye.